Hi, welcome to everyone's favourite segment, Mailbag. Let's get straight into it. This one comes from Martins Lasdens from Latvia. Hi to all my Latvian viewers. The name rings a bell. I think Martins might be having a second suck of the sav. Now, what's the deal with this plastic? I'm not sure. Let's go. What do we got here? It's a super something. Ta-da! We have foam. More foam. A board. Whoa! There's a note in there. Read that in a second. This looks like a huge board. Looks like a board. Feels like a board. Whoa! Hang on. This is a monster. Wow. Hate these. They've always got sharp pins on the back and everything else. Wow, look at it. 4-processor server motherboard. Wow. What a beast. I believe it's faulty. Geez, how many memory slots? 2, 4, 6, 8 for each processor. And wow. Whew. Wow, what a beast. I don't even know what size that would be. Is that like, is there a, like an industry standard for this particular size motherboard? There probably is. I don't know. Sorry, I'm not into server motherboards and whatnot. So it probably takes, you know, Xeons and or whatnot. So, wow. Thank you very much, Martins. Very nice. We'll take a quick look at it. Aha, I was just about to say that Martins was the one who sent me my Xeon motherboard. That he says that he sent sometimes, sorry it plus the Xeons was not able to fulfill your rendering needs. It actually was. I'm using it. Unless somebody sent me 2 Xeon motherboards. Anyway, yes, I am certainly using the dual processor Xeon motherboard. I think somebody else sent me some Xeons as well, and somebody else sent me some memory, and I've done a video actually building my Xeon rendering machine, which is what I use for rendering here. A lot of the limitation for my rendering actually comes down to various software and codecs and things. But no, the dual Xeon processor machine that I'm currently using is a beast, and it renders very quick in terms of, well, at least for doing things that can actually use all the multiple cores properly, like Handbrake, for example, doing transcoding instead of video rendering from my Sony movie studio / Vegas editing software, which is a bit slow when I'm doing 50 frames per second like you're probably watching this one at. But that's a codec issue, not because it can't utilize all of the Xeon cores. So, but Handbrake, it's super quick. So thank you very much, Martins. Well, check out this beast. It's a Supermicro H8QG6-F for those playing along at home. Yes, I'll link in the data sheet and all the paraphernalia down below, but let's have a quick look at it. 4 processors. No, this is not a Xeon, as I guessed before. It's actually a G34 socket here. That's for the AMD Opteron 6000 series processor. What ones it actually supports, I don't know, whatever. And we've got 8 DIMM slots per processor for a total system memory of 1 terabyte. Oh, what would you need that for? I don't know. But obviously this isn't your standard desktop or gamer PC. It's designed for server stuff, which can utilize all the cores, high throughput, all that sort of jazz. Standard PCI Express over here. And basically, well, there's, you know, like the CPUs do a good chunk of this. I mean, it's basically these days, I mean, all you got is the CPU, of course, in this case, 4 of them. You've got 2 Northbridge processors. These are AMD ones, SR5690 and SR5670. Not sure of the exact differences between these two. Haven't really gone into it. Anyway, so they're the Northbridges. Our Southbridge is here, this little puppy, this poor little sad thing under here, which doesn't get a fan. Oh, why are these ones so special? And we've got a Novaton baseboard management controller up here, a Gigabit Ethernet controller here. It's got 2 Gigabit Ethernet ports on the thing, and this is your SAS RAID controller down here. Look at how many, 2, 4, 6, 8, 10, 12, at least 14 SATA connectors. Unbelievable. And pretty much, you know, not a huge amount else. It's just really, you know, support stuff, power things, which we'll have a closer look at. Look at the amount of extra power connectors on here. It's, I don't know what the total power consumption of this thing, but it's an absolute beast. And if we have a look at the back here, not a huge amount on it. There's some support stuff over here. It looks like there's some sort of interface driver over there, a level translator, something like that. But yeah, it's basically just like a huge amount of controlled impedance routing. As I've mentioned in many videos, of course, you can see all the controlled impedance differential pairs going in here. This is why they're all funny and snaky. No, somebody wasn't drunk when they actually laid this thing out. They're length matching all of these, and that's the way they length match. They add little wiggles in there. And then you've got things like the under the memory here. They've got massive ground planes under there, even though this is going to be like a, I don't know, like a 12-layer board on something. I'm not sure of the layer count on this piece, but it's going to be absolutely enormous. But they put those whack on the bottom of the DIMM modules. And over here we've got some more routing. This one curiously has routing through like half of the DIMM connectors here. You can see all the VIA. You can see all the VIAs there from the DIMM connector. They're surface mount, of course. They're not actually through hole. So, but yeah, they decided we need some routing here, and oh, we don't need any routing here, so oh, let's just whack in a ground plane. These ones over here didn't need it, but obviously these ones up here did, and another one over here didn't. So that's all just a part of your layout considerations and things like that. There's our PCI Express slots over here. More stuff coming down. Look at it. Oh, beautiful. There's that. That's probably a level translator. Looks like an IDT. No, Cypress, is it? I can't see on the screen here. Anyway, power down the bottom, but a bunch of miscellaneous stuff. That looks like some power control. DC to DC converter logic down there. So let's have a look at the power supplies. And a massive critical part of getting a huge system board like this working is the power supplies. And look at these. They've got, these are all separate DC to DC converter chips. I haven't looked up the part number, but of course they're dead giveaways. Look at these big inductors here. And we're going to have, they're probably polymer-based electrolytic caps there. We've got our diodes over here. And there's a whole bunch of these, and there's just banks and banks and banks of these. What have they got? You know, how many of these do they need per CPU? Or these powering just the CPU? Some of them may be separately powering the memory, the DIMM modules perhaps. I don't know. We can actually flip this board over, and I'll show you those. They're the ones we saw before. There we go. They've got some additional controllers on the bottom there. Wow, and there's just, you know, there's like half a dozen banks of these things. So I'm not entirely sure how many rails the AMD Opteron processor takes and whether or not they're all dedicated to those. But yeah, I mean, each processor has its own bank. There we go. Another one up there. There we go. Looks like there's some regulation under there. And over there. Tons of it. We've got more down here. These would be powering the North Bridge here. Wow. Power everywhere. Power's everything. And there's the socket for you socket aficionados. Oh, look at all the little pogo pins. Aren't they pretty? Oh, look at them. Wow. No wonder these things cost a bucket load. One of the most amazing things about this board, though, is imagine what the production yield on this is like. Imagine trying to get right the soldering process on these connectors and all the DIMM sockets and all these huge, you know, these are probably 1000-pin BGAs as well. Just tons of them. If one little thing fails in here, well, the entire board is screwed. Imagine how much effort goes into just getting the reflow manufacturing process correct just to reflow solder this thing, let alone all the, you know, correct pad geometry for the sockets. Although once you've done that once, it's okay, but just getting the thermal profile right. I mean, you can't just whack this in your toaster oven and expect it to work. you wouldn't be able to just even whack this thing in a regular, professional reflow oven. Just get in the profile right and the process and the type of machine you actually need to reflow something like this and get everything correct, and the thermals of the board as well soaking the thing, and it'd be absolutely critical because there'd be a ton of ground plane in here which really heats these, A, takes a lot of energy to heat them up, B, they stay hot for a long time so they're difficult to cool down, so the risk of tombstoning and other issues caused by that is absolutely massive. Just I would not like to do this at all. I would not like to be an assembler going, we need you to make this and give us a high yield too. Ugh. So thank you very much, Martins, for sending that one in. Oh, definite keeper. It's like a, you can almost frame it, whack it up on the wall. It's beautiful work of art. And maybe we can, I don't know, do something fun with it. I don't know what. But yeah, it's non-working, Martin says. So yeah, it's a fail board. I have no idea what. Could be anything. But wow, what a beast. Thanks, Martins. Next up, one from Australia. Hi to all my Australian viewers. Bloody ripper. It's sent to that crazy Aussie bloke who loves Sony portables. I do like Sony gear. And yes, sorry, I still have a few Sony retro items for teardown. So maybe, hopefully I can do a Sony retro teardown tomorrow from the viewers of that crazy Aussie bloke in Queensland. Bloody Queenslanders from Brisbane. And it's some note foldy thing. Oh, there you go. That's novel. Hi, Dave and Chloe. Oh, here's another gem to add to the collection. Thank you very much, Andrew and Jim from an unnamed government department. I wonder what it is. Being up in Queensland, it's not like they're based in Canberra, which is where all our bloody politicians are based. There's my phone again. Oh, don't get too many calls here at the lab. It's just the wife. Let's have a look. It is a bit of Sony gear. Oh, in the original box. Look at this. Wow. What? Oh, I don't know. They've taped it inside. Okay, it's a bit weird. Okay, there we go. Got it. Figured it out. Dummy me. It's a Sony CD burner. 2-minute teardown. Mobility for enjoying DVDs and CDs. Behold this magnificence from the 90s. Hallelujah. Look at that. Oh, beautiful. Power burn. Oh, portable CD-ROM drive. So, yeah, I'm a little bit confused. It is actually a portable writer. It is a portable CD writer, but it can do playback as well. It can do memory sticks, and it's actually an audio playback device. You can, actually, it's a combo, weird-ass combo thing. And go the custom battery cradle. Oh, look at that. Now you can just plug this beast. How do you plug it in? There we go. Do we plug it? Yeah? I don't know. Oh, dummy Dave. There it is on the bottom. And this flips out and it plugs onto your cradle like that. Yeah. Bugger the 1990s. This is 2003 technology. Thank you very much. MP3 playback would have been pretty state-of-the-art for the time, wouldn't it? There's our custom rechargeable battery. Some sort of lithium job. And through the magic of YouTube, we're in like Flynn. Some decent shielding in here. I don't mind that at all. Geez, look, they've even got the little, little shielding tab coming over onto, is that the top of the motor there? I like that. But more interestingly, look, they're using flat flex as the connecting. Look, you can see one big conductor inside the flat flex there. They've even taped it down, thank you very much, so it doesn't flap around in the breeze. They've actually used that to, actually, is that spun off from that one? Oops, sorry. Terrible videography here. But yeah, they're using that flat flex single conductor to actually join the screws, to actually connect the grounds together. Very neat. No surprises for finding some Sony silicon in there. Sony do a lot of custom stuff. What's that 3U puppy there? I don't know. Google it. Oh, it's an ARM. Is that? Yep, there we go. ARM processor. Look at that. Genuine trimmer. Wow. What are we trimming? I'll tell you what, there's a lot of integration on this board, and check out the fit to envelope design in here. Look at that. This is obviously audio and power supply stuff, because there's our audio output there, probably audio output driver there, but all the caps in here and the inductors, all, you know, vertical parts. They need a fair bit of space, and they all fit into that envelope down there. Oh, spring fell out. Oh, it's not going to work anymore. And there you go, the old light pipe. Look at that, the choice of system designer champions everywhere. Little 0805 LED in there. That's the way to get the light out the side. Beauty. And more of the flat flex ground in from there to there, completely ruined by this ugly wire. Oh, even though it's crimped and done properly and beautifully and taped down, it just... So let's see what's under this puppy here. Why have we got some rubber insulators on there, have we? Yep, but ta-da! There's our drive mechanism. Nice. And I couldn't resist. And of course your laser diode's in there somewhere, and well, this one's a keeper. It's just fun. I don't know, might be able to do something interesting with it. And there's the eject mechanism as well. Look, you can see that arm in there. It's got its own little motor. Look at that drive on it, and it's electronic. So you push the eject button over here, and it's all the way, and all the stuff is over here. So yeah, not just manual. They went to a lot of effort for that. And don't you just love the jazzy little remote with these Sonys with the LCD? Probably plays like the track name, the MP3 track title or something like that. Ah, beautiful. Look at that. Rock that on your lapel. So thank you very much, Andrew and Jim from the unnamed government department. ASIO, hello. Maybe. I don't know. Thanks, guys. And yes, I am going through size order yet again, being a bit naughty. Just want to get the big stuff off my shelf. Thank you very much. Where is it? Rich. G'day, Rich. He's from the United States of America in Jamaica Plain, to be exact. Jamaica Plain? Not plains, just plain. There you go. All right, let's have a look that Rich has sent in here. It's multiple items. There's 3 items on the customs declaration. We have a note. You know, I usually just skip the notes. What do we have? Oh, the original candy water. The American classic, Necco. Never heard nor seen of them. There you go. Necco. I'll give those a bell. Oh, we have a crusty... Whoa, this was a... Hang on. Oh, geez, we've got a lot of... Some interesting stuff in here. Here we go. I'll just crack this open. I do actually have another unit up there. So once again, it'll be a multiple teardown. Wow. The Garmin GPS III Plus. I could only dream about that when I was geocaching back in the day. With a little compass as well. Beauty. Looks like it's been well used. Got some Velcro on it. And interesting wedge shape. So like it can sit like on a bench like that. I guess like, you know, maybe good for boating and stuff like that. Perhaps you can like wedge it up in the console or something like that would be my guess. Anyway, that was probably the duck's guts back in the day. It's going to have a helical antenna in there. And beauty. Wonder if it still works. Probably does. They're super reliable, these things. All these old GPSs I've looked at, they always still work. Weird-ass custom 4-pin connector on the back, but awesome. So we have a Garmin GPS. I've got another GPS, I think. And we have a probe-style oscilloscope. It's a Rat Shack. Rat Shack for originally $89.99. Wow. There you go, Radio Shack. Oh, it even comes with a 3.5-inch flop. Yeah, probed, for Windows and DOS, version 4.1. So got a date on this thing. 1996, Tandy Corporation, all rights reserved. Oh, geez. 2-minute teardown. Beauty. The original candy wafer made in the United States of America since 1847. These are equivalent to, I guess, fruit tingles here in Australia. I'm not a big fan of the cut wafery thing. I think I much prefer the fruit tingles. Tastes exactly the same. All right, let's see if this Bobby Dazzler still works. Woohoo, it does, but look, some lines on the screen there. It's the GPS 2 Plus. Or is it 3? GPS 3 Plus. Searching the sky. I don't think it's going to find too much here in the middle of a concrete building. But check it out. This puppy rocked a full 12 channels back in the day. The original model, well, the manual for the GPS 3 dates to 1997. But this Plus addendum, this is the GPS 3 Plus, dates to 1999. So let's party like it's 1999. Wow, check it out. That's surprisingly bodgy, but geez, look at the RB electrolytic here. Just it's glued. At least it's elastic down to the bottom there, but they got the leads going all the way out there. It's like it was an oopsie, and oops, we've got to add some capacitance, or something's not quite stable enough, and even this puppy wasn't enough, and they had to add this one over here. So what's going on there? Anyway, here's our receiver, and that's coming from our helical antenna. I don't need to rip all that apart. It's just a 2-minute teardown. And with that under the can there, which is soldered down, by the way, I won't take that off. Probably maybe an old first-generation Surf chipset, perhaps. I'm not sure of the exact date on that. Probably around there. Little bit of, look, a little bodge on the RTC crystal there we go, 32.768 kilohertz watch crystal, and then they've just elastic that down, bit of hot snot there, down. Why they didn't use a proper surface mount job? It's just surprisingly a little bit how you doing for like a leading edge Garmin product. Well, there's something you don't see every day. Intel 386EX processor down in here. Wow, that's a fair bit of grunt. Why, maybe not optimized for the job. Maybe they chose that because the development was easier, perhaps. But yeah, that'd be sucking a bit of the joy juice. You can tell this thing's designed for the marine environment, the big rubber seal around the outside here, and the rubber seal on the custom power connector at the back here, and some of the screw in here has some elastic on the bottom of it. And do we have? Yep, we've got a rubber seal around the battery compartment there for the 4 AA's. Yep, this is designed to sit in a boat, maybe, like in the front console or something like that. Whip up your helical antenna. You've got to have an erect helical antenna, and Bob's your uncle. And Rich reckons there's a myth about these Necco wafers. These things were inspired a useful manufacturing shortcut for the first radar systems during World War II, but every trace of that tale seems to have been wiped from the internet. At least they taste slightly better than something you'd find out of, 1940s electronics. Excellent. Oh, look at this thing. Includes Windows 95, MS-DOS compatible software. Wow. Because, you want to get serial out of your handy scope. Your probe scope. Sorry, cat number 22310 for those playing along at home. Oh, beautiful. Ideal for on-the-spot testing of electronic circuits. Selectable input ranges, 1 volt, 10 volt, 100 volt, 20 meg max sampling rate, 5 meg effective bandwidth. None of this equivalent time sampling rubbish. And on a 16 by 32 pixel LCD. Oh, goodness. The Radio Shack probe scope. But look at this. Custom manufactured in Germany for Radio Shack, a division of Tandy Corp in Fort Worth, Texas. And of course, the thing with this, there's no ground attachment on the front, none of this high-frequency probing rubbish, designed to connect to the circuit under test. So, yeah, you managed to find a point on your board and hook these puppies up, just like logic probes back in the day, And, yeah, so you don't need the ground attachment there because it's coming through the system ground over here. Goodness, look at the loop. Anyway, it's going to be absolutely horrible, but, I guess it served a purpose back in the day. It's a live probe scope. It requires 9 to 15 volts in here. But, yeah, look, okay, what do we do? Probe scope. Neat. Somebody went to a lot of trouble to do that. AC-DC coupling, thank you very much. And ground. Gee, it's got everything. It's even got a funky 0 level knob. Oh yeah, I play with that thing all day. Okay, so how do we actually make it work? Do we push this button? I assume we push this button here because it's just sitting there. Oh yeah, there we go, version 3.0, 1995, here we go. So it wouldn't even power on, you had to... Oh, there we go. We're in. Ta-da! Oh, I can make it do something. Can I pick up 50 hertz hum? Here we go. How do we change the time base? Press it. Oh yeah, there we go. 100, is that 100 nanoseconds? 0.5 microseconds, there we go. We're going to get there. It's actually, like, you can just go in one direction. That's it. There we go. We're starting to see it. We're starting to see it. Hold on to your hat. Ta-da! We have our 50 hertz hum. Look at that. What a Bobby Dazzler. And here's inside. And Germany, all right. Who or what is Bob Lingen? G'day, Bob. Oh, look at that. The LCD's just hanging or flapping around in the breeze there. That's just that's a serial interface job. You can see the number of pins, very small. Looks like there's a micro with some firmware. And what's that puppy? What's a ZMD U1825? Wow, a Cop 8 processor for all you Cop 8 fanboys. There's got to be a couple left out there. There you go. It's actually a Wittig test technology. It's the Aussie Fox. Beauty. That's not Aussie, that's Aussie. Aussie. Oh, right. Yeah. No. Fail. Anyway, Wittig. Somehow I don't think there's much overload protection going on there. Straight over to the switch down here and, well, yeah, there ain't much in there, is there? Thank you very much, Rich, for sending those items in. Interesting teardowns. Urgent! Crowdfunding ends 30th of March. Awesome. Let's crack it open. Thank you very much, Ben Wang. He's from Crow's Nest here in Sydney. So, oh, that was the red zipper thing. The red zipper thing failed. Oh, bloody. This is a genuine Australia Post envelope too. Oh, what a load of garbage. Anyway, geez, you're going to put the red pull tab on there. Make sure it bloody well works. We've got a bare board. So, let's check it out. And Ben's had a second suck of the sav here. He's from North Sydney Boys High School, Year 11 student. And you might remember it's a new improved version of what we've seen before. The board, the Perf2 allows any 2 points to be connected together with 0 wires and some solder bridges. Project is currently over 200% funded. Beauty. And we'll end on the 29th of March. So I'll link it in down below. He's just soldered a couple of things on here to show us how it works. And he did the remote boot thing. So what, third suck of the sav? Here it is. It doesn't look very impressive, but it's a proto board. That's the whole idea. Let's have a quick squiz. So if we take a look up close, you can see that the traces going one direction here. So it's a big strip, just like a Vero board. So it kind of combines like a Vero board and matrix board, but you can actually but by default they're all disconnected as opposed to all connected together with a Vero board, and then you have to cut away. These ones, if you want to join them up, well, you just do little solder blob like that. It's tiny little, what is it, I don't know, like 6 thou, 8 thou gap or something in there, and you just put a little solder blob across. And of course all the ones, they go in different directions. So just like routing back in the old days, these ones go vertical and these ones go horizontal. Very, very flexible. I love these things. So say, for example, this Atmel processor here, you've got that one trace going directly down like that. So if you wanted to, you could just solder, you know, if you have to join that pin to that pin, no worries. You just join those two together with that one strip. And then on the other side here, you can actually, then you've got them going in the other direction. It's quite flexible. So like all these proto boards like this, I like this one, and they've each got their own unique niche use. So it's worth having like there's no one board that is, you know, one prototype board that's suitable for absolutely every project, every requirement that you come up with. So it's worth having many different types of these proto boards just in your junk box so that you can, you know, whip them out and do a quick project. This is quite neat. Well worth having in addition to your standard Vero boards, in addition to your, you know, your more functional ones for all your surface mount stuff and things like that. Definitely. Good work, Ben. Oh, I only saw the second page of this thing, and Ben's got himself a patent on this thing. Do you believe it? The Field Configurable Electrical Routing Matrix for Electronic Prototyping. Well, okay. Good on you, Ben, if that's your thing, if that floats your boat. Next up, one from Deutschland. Hi to all my German viewers, which is a very significant part of my audience. Thank you very much, Ike? E-I-K-E. Shaft, thank you very much. I don't know, Ike. Call you Ike. That sounds better. Sorry if it's wrong. Ooh, nice flowers on the postage stamps. Anyway, let's check it out. It's a, okay, I'll maybe give you a bit of a spoiler. It's something Texas Instruments. So, let's check it out. Dun, 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 dun. What will it be? Wow, oh! An Ibico 83 calculator. Wow. Oh, what a simple four-banger, as they're called. Well, in the calculator world, the four-banger is a four-function calculator. And, geez, yeah. Oh, wow. Made in Japan. All the best stuff's made in Japan. Woo. All right. Let's have a look. Thank you very much, Ig. You sent a note, but here we go. That's not the Texas Instruments thing. This is the Texas Instruments thing. When they came in a handy carry case. Yeah, just rocking up and just cruising the streets, you know. Yeah. I'm ready with my, whatever it is, the TI 5029. Oh, look at that. Wow. Rocking the streets with your... Once again, it's a four-banger. It doesn't even have... it's got totalizing and stuff like that, but it doesn't really have any financial stuff. It's not really like one of those proper financial calculators either. It's one of those printing calculator thingamabobs. We've even got the old roll. And, I don't know, accountants still use those. Apparently they still sell them. Go figure. All right, 2-minute teardown. So I can send in these two puppies from 1975 here, this Ibico, and this TI for all you TI fanboys out there from about 1990. And check it out, vacuum fluorescent display. Oh, isn't that a thing of beauty? Wow, and it's a Sharp for the win. Check it out, it's alive. Well, it's doing, oh, yep, there we go. Yep, there we go. It's a winner. Winner, winner, chicken dinner. Beautiful. Wow, Krusty, check it out. And we've got ourselves an, Epson Printer. There we go. You're just playing along at home. Marked 1990. There we go. But look at this. There's nothing in it. But this puppy, look. They've converted the dip into surface mount. Well done. Well, overall, that's just a pretty horrid, bodged together piece of crap, really. I mean, look at these, look at the caps just tacked on the back here. You know, this is production, but, you know, I don't know, labor was probably cheap in 1990. There we go, you can see down in there how they print the things. It's effectively like a daisy wheel. We got ourselves a FedEx one. Thank you very much, Edward Hopkins, who I presume is from... Oh, no, I was going to say the US, based on FedEx and, well, FedEx operate everywhere, but, you know. Anyway, from Senegal. Thank you. Hi to all my viewers in Senegal. I wonder, I'm not pronouncing that correctly, am I? Senegal? Senegal? Is it Senegal? I don't know, that's how us Aussies might pronounce it. Anyway, I don't know. Oh, postcards. Presumably from... the country, which I can't pronounce correctly. Look at that. Beautiful. And a victorious looking dude. And it turns out Edward is actually formerly from the US, originally from the US, now in Dakar, in Senegal. Awesome. And we've got some, look at this. Makes the skin crawl. Look at it. Ta-da! Cheapy. Look at that, one of the $2 cheapies, which we've seen before. Don't know if we've don't know if we've done one of these before though, but you know, can't leave out the old analog. check it out. Oh, the specs on the back, which are no doubt thoroughly impressive. And it's a Sanma brand. I'm trying to play off Sanwa, which are, of course, the highly regarded Japanese manufacturer of analog meters. So, yeah, that's just, oh, that's terrible, Muriel. Wow. Apparently, these things cost $1 and the other is 60 cents. Are you kidding me? Oh, wow. It won't take 2 minutes to tear down these. We'll just open them and point and laugh. All right, let's play Spot the Error in the labeling. Gotta be kidding me. Wow, this has to be the world's best analog meter. Look at this, 0.5%. Look on the 200, all the ranges. Unbelievable, with a 1 meg ohm input impedance. Brilliant. How they get the 200 millivolt range out of that, it's magic. This should say, warning, to avoid electric shock, throw immediately in the bin. Well, it doesn't get any better than that. Oh, superb soldering job. Oh, it's just can't be beat. Look at this. Is there any better multimeter than this? I haven't seen one. 3.5 digit display, you say? Okay. And don't you just hate it when these companies rebrand? It's just bloody HP all over again and Agilent all over again. Was Sunwa. Now it's Sunma. I guess they didn't want the electrons to fall out, or do they? With the M to the W. Just a little rule of thumb. Beware any multimeter that comes shrink wrapped. Luckily, the battery comes pre-installed. Hey, no worries. All it needs is one of those 9-volt batterizers they're promising. We'll get 800% more battery life out of this thing. Beauty. That shot's got meme written all over it. We've seen this exact model before, so, yeah, no comment required. So thanks to everyone who sent something into today's mailbag. If you liked it, please give it a big thumbs up. Catch you next time.